All right, here comes my audio. Hopefully you're hearing me. I'm not really completely set up here, but I believe that I'm just going to need to begin anyway. So here I am. Here I come. Oh, I'm very orange again today. What's happening with the lighting? Why does this keep happening? Huh. Oh, and the focus is not focused. Oh. What did I do here? So I can change this lighting temperature and to focus the camera. Let me make it a little brighter. No. All right. Sorry, everybody. So I have a little bit of an issue, which is that, is this what I used before? Which is that I should really do this before I turn the streaming on. There we go. I just had the color temperature on the light kind of wonky. So I think it's better now. But the issue that I have is that now that I'm not using autofocus on the camera, I have to focus the camera because I do believe that I am a little bit out of focus and I am only one person. And so my method for this last time was to tape something up around here. Like, so I'm getting some text messages. This is definitely what you all tuned in for. The focus resets when I turn off the camera. Why does it do that? There's no reason why it should, right? So if I put this here. Last time I pulled the desk back a little bit. I don't know that I have the patience to do that right now. There are also other focus settings besides continuous autofocus. I wonder if I use something that's less extreme, that it only changes the focus if it's based on like where my face is or something. All right, but I can at least focus on this. The desk is on wheels. So let me try to focus now on that, which will certainly improve things. Okay, I think out of focus. Very hard to see that. I need to zoom in. There's a zoom button somewhere on this camera. Autofocus. Oh, is this the zoom button? How do I zoom? Well, this is I need to allocate time to mess with all of my stuff while I'm not actually live streaming. I'm supposed to do this stuff in advance. Okay, wait, I can see it pretty well. Oh, there we go. Okay, that's pretty well in focus. Let's see if this will just do for today. I'm coming back around. It looks ridiculous. But I think I'm pretty much in focus. I'm looking at a preview here, and it looks okay. All right, so hi, everybody. Thank you for tuning in. You really don't need to be here today, although it's helpful to have you here. Just to set the stage for what my goal is, and and I have a first-time chat from Sally the Goose, who wants to know who made your background. All of the Coding Train materials are created by, illustrations and characters are created by Jason Hegland, who is the illustrator for the Coding Train. This is actually the Happy New Year background. I just never changed it off of that. I guess it's March now. I probably can't keep the Happy New Year background. All right, so by the way, I need a crash course in what all the little icons next to people's name mean. Like Simon has a star and a kind of like almost like diamond, and KFon22 has a star. What do these things mean? I love seeing, by the way, nothing makes me happier than first time chat from viewer because they feel like, oh, it's a new person. So diamond equals VIP, star equals a sub. Okay. If you leave it a bit longer, it'll be appropriate again, says Me I Am So Me. Thank you. Oh, Me I Am So Me is here. Good. Very helpful viewer. All of you are helpful viewers, but Me I Am So Me, I love your name so much because remember there was like a time period where I was saying, I can't remember what I was saying, but I didn't, Me I Am Some? I was just saying, Me I Am Some, Me I Am Some. All right, so let me talk about what I want to do today, and I'm going to close out my Twitch dashboard here. Oh, I should have it open over here. If you'll just bear with me for a second. Again, you're already bearing with me for quite a long time. I just want to open up twitch.tv. Oh, and Povo Gamer says, I thoroughly enjoyed coding a Discord bot YouTube videos. I'm really glad to hear that. I'm really sorry that those videos have kind of lapsed. Oh, the train is called found. Did I configure that? Or is that actually like the default founder icon for for Twitch? Couldn't possibly be a train, right? Okay. So hold on. I just want to get my video producer, stream manager up. First logo is founders. Okay. All right. So now I have the chat and everything in multiple places. Apologies for my lack of preparedness. Oh dear. All right. I'm currently not looking at the Discord chat. So it is a train for every channel. It's the hype train. It's a Oh, that's amazing. I love Twitch. The thing I love about Twitch is I feel this like enormous like pressure relief. Something about the YouTube channel with this sort of subscriber base that I've built up over the years. I feel like this extraordinary pressure when I'm streaming there. But I as much as I want to be chatty, I do have some specific things that I really need to do during this session for the next video that will be published on the coding train, the Mandelbulb video. And so let me bring you over to my computer screen here. Let me see if I can find this. Okay, so this is the code that I wrote. And I just want to put it back into, I'm going to put PZCam back. And I'm going to keep string list there. And I can take out this translate and this rotate. Okay, let's just make sure this still works. All right, so this is the Mandelbulb fractal volumetric point cloud that I created in my previous live stream. And I've been feeling very kind of disappointed about it, but now I'm kind of back to being excited about it. But let me just at least, order 8. So this is, I think it was 2 is the other page that I was on. Yeah, because it doesn't look anything like this render. If I put them next to each other, but you can see if I try to line it up that I have definitely created. The math must be mostly correct, if not exactly correct, given how those two match. And what I did, if you recall, if you were watching, is I attempted to take this point cloud and make it into a mesh. And I have since done some research and found some other resources. And let me pull some of these up. So let me, Inigo Quiles has kind of this incredible article explaining explaining how to use sign distance functions and ray marching. And then there are lots of shader toy examples. There was one that I wanted to look at, which was like called Simple Mandelbulb, I think, but let's look at this one. Hello, Trespasser. It kind of looks like the reference. Yes, Bruno, it does. So I want to kind of explain or basically re-record the ending to the Mandelbulb coding challenge, which is currently coming in at a little less than 30 minutes. There was also something that I did that I feel like I should issue a correction. It was kind of bothering me as I was watching the sort of edited version that Mathieu and I are working on, which is this. I feel like this and what is over there on? Oh, right, because I also recorded the nature of code. I'm like, what is over there on the whiteboard? I don't recognize that at all. That's not the Mandelbulb, but that was from the other video I was doing. So I don't have unfortunately, I don't have my whiteboard formulas written out, but I feel like this was named really unfortunately because this should really be like zeta spherical, right? Maybe there's a better way to call that, because let me use the whiteboard because I think that'll help. Which I did not. I'm just going to use over here. I don't know that I need to. So in the Mandelbrot formula, am I going to want to reference the whiteboard? Let me just erase this. Oh, it's erasing just fine. Okay. Yes, this video will have time travel. All right, so let me try to talk this through. Oh, let me record everything I'm doing to disk just in case. So bear with me for a moment while I do that. I'm coming back over here. And why again? Oh, I don't have the fluorescence on. That's also why the lighting is so different. So, we're going to redo the lights in here. I forgot about that. So, sorry, I'm coming over here to turn the fluorescent lights on in the garage, which actually makes quite a difference in the general lighting in terms of the whiteboard and everything. So, coming over here. All right, so I am going to record to disk by opening up this. And why is that flickering? Okay, it's fine. I'm just going to start recording. Okay, so I'm now recording everything I'm doing in case I need any of it, although right now I'm still just sort of working through the problem. So issue number one is that the formula for the Mandelbulb, it's the same as the Mandelbrot, just we're dealing with a 3D vector instead of a 2D vector. Z is a triplex number. Z to the n, Z equals Z to the n plus C. So in my code, Z is zeta. To calculate this, I take zeta spherical to the nth power, and then C is actually just the raw x, y, z. Oh my God, you don't see the whiteboard. I'm sorry, everybody. Sorry, everybody. Wrong camera. I was recording that, though. Sorry, apologies for being in the wrong camera. Again, that's another future someday coding train project where I'll just have some sensors based on where I am. It'll switch automatically in OBS. That'll be a great project to work on. Add it to the list. Who's keeping track of the list for me? Nobody. So this is the formula, and this is what I'm calling zeta in my code. This is just the actual where am I? Which point in space am I testing? X, Y, Z. And so, but what I did is I called zeta spherical C by accident. And that's a problem. It's not a problem in executing the code and making it run, but it's super confusing. So I feel like I should break into the video and maybe explain that. I don't know whether I need this full whiteboard explanation or just to say it, but so that's what I'm going to do first. So I'm going to record that correction. Any comments? The camera in the green screen got the white balance messed up after turning on the lights. All right, do I look now? Do I look too washed out? Because I can go back to, oh no, that's the wrong direction. Like, let's see what it looks like now. I'm just curious. Do I look, is this more like, I think this might match more like what I've had before. Yeah, Rogush. So what is the little like, so, but there's also a first. I thought first was the founder. So how is first and the train different? And then also there's the little like crown. What's the crown? Maybe too yellow. Rogu's subscribed with Prime. Thank you, Rogus, for subscribing to my Twitch channel. I hope that you figure out a way to connect your Twitch account to Discord and you join our conversation in the subscriber, member, patron Discord, although there is an open Discord for everybody, so you can also join that. Crown is Twitch Prime users. Gives 1 month of free subscription on Twitch. I can hover over the icon. 1 month subscriber. Got it. Nightbot. I don't know why Nightbot really doesn't want to. I'm sorry, Unicorn Coder. Nightbot has some settings that I should probably adjust. Okay, thanks for all of these. Excellent. Sorry, my chat is over here today instead of like here. I should set up. Okay. Let me cool off the lights a little bit. I'm going to split the difference. Put this to 3500. Okay. And hopefully that's going to look fine. All right. So this this is really like z to the n, right? Z to the nth power, z to the nth power x, z to the nth power y, or zeta, but we can keep new x, new y, new z. And then this is really c. So this should really be like z spherical. Is that a good name for it? All right, I think you're right. I think I could just do a really simple break into the video and just like explain that. All right, I'm just going to add, before I start to record this quick correction, does anybody have any comments about the color temperature? Hold on. I have to answer this text message. Just bear with me, please. Too many things going on. Okay. Looks reasonable. You were recording the feed separately. Color correction could be applied in post. That is correct. Too hot. I'm spitting fire. Let me just go back to what it was before. I'm just going to put it to what it was before, because there's no reason why I should be changing these settings. This will match whatever I recorded it as. Okay. But yes, it can be color corrected. All right. This isn't even the more important part. I only have till 4 o'clock, which is actually a fair amount of time here. But all right. So let's try me doing a quick correction here. By the way, people are asking about the boiler. So it's very warm in here. So it's 43 degrees Fahrenheit outside, and I had the heaters running for a bit. It's sunny. Oh boy, do I have an announcement to make. Well, let me finish saying about the boiler, but then I will get to my announcement. So I turned it off. But last time I recorded, I left it off overnight by accident, and luckily nothing froze, no pipes exploded and burst, but it's fine. But I need to remember to turn it back on when I'm done. So people should remind me that as I'm wrapping up. Although my announcement is, and I'm just gonna really check, I'm gonna check here to see how it's going, is my solar panels are active. So what you are seeing right now, everything that I'm powering right now, I'm about to check, is I'm getting 12.6 kilowatts of solar energy right now. I am currently using 2.8 kilowatts and sending 9.8 back to the grid. New York State, you're welcome. You're welcome, New York State. Central Hudson Valley, you are getting some of the power from the solar panels that are on the roof of my garage right now. And I'm really excited about that. And so I'm also, that boiler is from the 1970s. I mean, could last longer, but we're going to pull it out and put in electric heating. So I will be fully electric with solar power. Won't have this sort of boiler issue much longer. So I wanted to mention that. So the coating train is, yes, officially solar powered. This is one of the wonderful things about where I am. This garage, which is huge, has a really long roof that faces south and is wide open with no shade, and it just gets sun the whole day. So I have, yesterday was the first day it was active, so I don't have anything really to report. But I'm hoping that I have enough juice from the solar panels to power everything and then some, I still, in the main house that's separate from this garage where I've set up the studio, I still have oil-based heat. I think that's going to be much more involved if I want to replace that. But the garage is simple. Nothing is that simple, but it makes sense to pull the boiler out, just have electric heat in here, get rid of this oil tank, power this room by the sun. Okay, so yes, and Hampel Wright makes a very good point, which is, I don't understand. I thought you live on a desktop. Yeah, nope. This is all an illusion. There we go. I'm going to blow your mind right now. It's just a green curtain. This needs to be out of the picture a bit more. How's this audio, by the way? I'm really happy with this mic so far. Worthwhile investment as far as I'm concerned. And it's running off of a rechargeable battery, so no more. I mean, I had been using AA batteries in a mic receiver for a really long time, which is so wasteful. It's really bugged me. All right. Sorry to interrupt. I wanted to come back from the travel. Sorry to interrupt. I wanted to travel from the future back here to let myself know, or let you know, the viewing audience, that Oh, yeah, yeah, all right. Um, I don't want this to take a lot of time, so I've got to be cautious. Sorry to interrupt. I just wanted to break in for a moment from the future and just acknowledge the fact that I've really unfortunately named this variable C. And we could use the old whiteboard. We could pull in the shot of the old whiteboard, but I'm just going to use this one right now. I'm not going to go stand in front of it, Mathieu. If you look at the formula on the whiteboard, if you look at the Mandelbulb if you look at the equation for the Mandelbulb, Z equals Z. Oh! I forgot to turn this heater off. Do not need you to be on. If you look at the equation for the Mandelbulb, Z equals Z to the n plus C, there is a variable there already named C, and it's not that one. C is actually C is a reference to the point in 3D space. C is a reference to the point in 3D space that we're adding, x, y, z. What I'm calling C somewhat accidentally, I don't know what I was thinking. What I'm calling C here, I don't know what I was thinking, is actually the spherical. Let me do this whole thing again. Because it's going to be too many like jump cuts inside of a jump cut. It can be more continuous. Sorry to interrupt. I really just had to come from the future to acknowledge the fact that this variable C is really unfortunately named. If you look at the formula for the Mandelbulb itself, Z equals Z to the n plus C, there's a C in there, yeah, but it's not that C. Why did I call it that C? Ah! The actual C, the constant, is the triplex number, x, y, z, that I'm adding iteratively each time through this loop. That spherical coordinate is just the spherical version of zeta. So this maybe is a more accurate way to write it. Not that these variable names are that great either, but it's better than putting a false C there. So the rest of the video is going to continue with the C there, but I hope, in case this was a point of confusion for you, that this helps a little bit. As you were. All right. In JavaScript, you can name your variables with emoji. You had me at dad joke. Yeah, so anyway, I'm going to go back here. All right. So that is correction number 1 for that video. Hopefully that's good enough. I can redo that again. Let me just go to my recording, make sure that we actually recorded that. I'm going to hit stop, and I'm starting recording again. All right, so the next thing here is quite a bit trickier. Whoa. Whoa, I had not seen this one. Oh, this is actually... Whoa, what the... Simple. This is not what I wanted to look at, though. Simple Mandelbulb shader toy. There we go. Okay, so there's this. There's this page. By the way, this is a gold mine. Inigo Quiles, who I just discovered. Yeah, this is what I'm looking for, I think. I mean, this, you have no idea the amazing stuff that's in here. I mean, I could spend my life on this website. This is great, but it's not what I was looking for. Yeah, this is what I was looking for. Okay. And then yeah, this was also really, really, really good. Okay. Okay, so then there was also Blender, Mandelbulb.
I recently uploaded a video of a...
This really excellent reference. And then there was, I actually have a ray marching example that went along with the ray casting. Oh, no, it's not here. I was like, oh, let me see if I can find a simple ray marching example in P5.js. So I searched ray marching P5. And then I opened this, and I'm studying the code. I'm like, okay, let me look at this code. All right, what's going on here? Let me run this. Oh, interesting. Yes, this is ray marching. Okay, I see what's going on here. And I'm looking at this, and I'm like, okay, well, who made this? And I was like, dun, dun, dun. I was like, wait, I made this? But I think this might be something that Dusk created with a slightly different, as a variation of the ray casting thing I was working on. I'm not sure. Maybe I made this. I don't remember. It's so funny. Because I did not do a ray marching coding challenge. Maybe in that video. Let me just look. Ray casting coding train. I can very quickly just scan through this video.
Hello and welcome to a coding challenge.
Like sometimes at the end I'll give lots of extra examples. Was it one that I included for that? I don't think so. I also think this was before I started really like working with Mathieu to add a lot more production stuff to the videos. Yeah. Yeah, this is a different thing. All right. I wish there were examples of 4D quaternion Julius set ray marching. Yeah. Just looking at all right. So, oh, and Fuetrager. All these people are subscribing with Prime. That's very nice of you. Fuetrager. Thank you for subscribing to the Coding Train. I can't believe you did that in this live stream where I'm doing absolutely nothing but poking around websites and talking. But I am, I think, going to now do something. Sorry, I was like, I'm looking at my recommendations over here, and I'm like, I have not watched this. I did check out this. Okay, rendering ray casting. Did I do it for this one? Okay. Anyway, I did a follow-up. Yeah. It's funny how I have no memory. I mean, this is like one of the funniest things about my life, which I'm demonstrating to you now, is I'm constantly like looking for a tutorial on something and I find my own thing on it. I'm like, that doesn't help. Or then I have to like rewatch it or reread it. Anyway. Okay, so I'm just trying to decide if I want to take a very brief amount of time. Like, let's look for a moment. I don't think today is the day that I'm suddenly going to do a deep dive into shaders and make my own SDF version of it. I think I'm going to have to build up to that. But I'm just curious to go here and see what the examples here are. Which one of these do we think is most likely to match? Probably the landscape, if I'm guessing, is, oh yeah, look at this. Okay, so this is a shader from Inigo Quiles. And it was ported by Raphael. I wish I had could get Raphael on the line here. So this is so this is probably one of these like amazing magic SDF things, which is basically just using a signed distance function and coloring it and lighting it. So this could probably be adjusted. There's no shader editor in processing. So I'd have to, oops, okay, hold on. I mean, this is not going to be I'm not going to succeed at this here. Oh, but I do have okay. Data. Oh, it's in the data. Open with VS Code. Let's see. A second here. So I'm going to open this. Why am I doing this now? I'm going to open this shader code in VS Code. Fine. No. Okay, fine. Update all the things. Then I'm going to, what did I call that? So let me open up this. Okay. Oh, let's see. Anybody know what syntax highlighter I should use? Clang format. What is Clang format? Let's just use let's use this one, I think. Ray marching is from this live stream. Okay, hold on. I guess I can open up the Twitch chat here. Oh, did I make it and then never include it in the video? Oh, yeah. Wait. So I wrote this code and then just didn't, or is that somebody else's example? Okay, I can go back and watch this later. I wonder if I could do CPU-based ray marching. Ugh. I'm like obsessed with doing things like this that don't actually involve the GPU. CPU, oh yeah, this is what I want to do. Yeah, exactly. Look, the world's foremost leading expert in ray marching, clearly. Every single thing references his work. Raymarcher.js. Oh, this looks like something I could accomplish. I mean, not right now. And I could use P5 and P5 vector. Interesting. CPU ray marcher. Okay, this is wild. Yeah, this is what I want to do. Let's go back to the 64 by 64. Yeah, like could I make a CPU render of the Mandelbulb probably using this technique? All right, but I've gotten off track. Let's go to the GPU one. I mean, I just should learn shaders. They're not going away anytime soon. That should really be the next big thing here. All right, but I was doing something. Oh, right. I was here, and then I was opening that shader. Right, I was installing this, and then opening this. Okay, great. So I just want to see here, like, okay, this is using like a noise function. All right, where is the actual main? This is insane. Color, whoa. Is there like a light? Oh, yeah. So I'm just looking through this code for a second. So this is, so, let's see. Calc normal. I just want to like try changing something, but I'm not sure what to change. Noise. I'm sorry, I'm like, R. Is this like the red value? I don't know. Mix, oh my God. Okay. This is so crazy. If cyan. This is crazy. Color multiplier. Oh, I see. So like, oh, that's if it's in stereo? First time chat even has macros. All right. Okay, I need to start from a simpler place. I wish that, and I don't actually, it probably makes more sense for me to go back to my P5 shader, which I did. Yeah. These are shaders I made back in October when I was attempting. Right. Right, I remember doing this now. Yeah. Okay. So what I would like to do just very briefly, and I'm going to only give myself, I'm trying to think, like 20 minutes, because I do need 30 minutes. Let's give myself 30 minutes. I'm going to allow myself 30 minutes of time just to explore SDF rendering in a shader using P5JS and P5 shader. So I can minimize this, and I want to explore it based on starting with this. So I keep getting to the, oh yeah, let's look at this one. Oh, how come this isn't, oh, accept? Why is this? Okay. Is it just being slow to load? All right. Just to catch up, I've got some first-time chats from various viewers here. I am giving myself 28 minutes to just explore the idea of a signed distance function, because I actually think that I might try to well, I definitely want to do a video about ray marching and signed distance functions as a follow-up to the Mandelbulb video that I've already made. But I'm probably just going to allude to that at the end. Why is this? Like, is this just a broken link, or? Oh. Ooh, okay. Subscribe. Notifications, all. Oh my God, I have to watch this more later. Oh, this is so good. I just love it already. Not even watching it, but I find whatever this is to be amazing. But that's not what I wanted to look for. YouTube tutorial. I want any of these. I want this sphere one. I just want to make a sphere. Okay. Sphere SDF. Shader toy. Maybe shader toy is like not loading right now. I'm going to be totally stuck here. I did see there's another really great reference that I just saw. Oh yeah, Jamie Wong. I was looking at this site as well. Yeah. Okay. Okay, I don't need to move the camera. I just want to. Oh yeah, shader toy is like not loading. Hi, DX8Pi, longtime YouTube watcher, first time here. Yay, thanks to everybody for being first time here. So I'm really stuck here because shader toy is, can people tell me if shader toy is working for you? Like, is it just like a temporary issue that I'm having? Like, I'm not getting shader toy as a website to load. Is like AWS down again today or something? Now it's loading. Oh, there we go. Okay, so this is perfect. This is what I'm looking for, okay. So I want to start with this. Come on. How do I get to this? Remarching part 1. There we go. Okay. There we go. Okay. So I know that shader toy is got its own weird sort of way of doing things, which is different from P5. But let's see what I can bring over, like sort of bit by bit. So let me come over here. So I assume I'll need these variables. And I'm going to need this signed distance function, which is just for a sphere, the length of the sample point minus 1. Okay. And then what is scene SDF? Signed distance function describing the scene. Signed distance function for a sphere centered at the origin with radius 1. Okay. Wait. And this is the sort of ray marching algorithm, which takes an I, a direction, what's start and end? And I have to get the estimated distance. If it's less than some incremental value, keep going. If it gets to the end, what's the start and end? Okay, well, let me keep these functions. Ray direction. Oof. Let's bring these functions into P5. Just curious. I mean, I could manipulate this in, all right, somebody's dinging me. Who's dinging me? I don't have, if it's important, let me know in the shader toilet. Ray shaders used with R. Okay, now, this is main image. So this is like a shader toy thing. So this is what I have to figure out here. So let's come into P5 and so this is fine. So let's see if I can figure out and let's just make this smaller just so I can see it there. Okay. Oops. Oh, that's fine. I shouldn't have duplicated, but no, did I already duplicate it? I don't know. Shader SDF experiment. Sorry, I know I'm standing in front of the code. Let me move this over. Okay. So now, what's in the? So this is the fragment shader is what I'm working on. So in the example that I'm looking on, let's bring this over here. And bring this in here. All right, comment this out. Great. Okay, I'm good. So I'm setting the color to 100 with, so I'm seeing red. And if I were to change this, I would see green. Now, the question is, how can I change this to work with this ray marching? So first, I'm going to make a direction, 45-degree angle, I resolution. This is the GL frag chord. And what is I resolution is my U resolution. I think that's what I'm getting from P5. So I think that, no, that would be the equivalent here. Error compiling, oh, because it's capital F. Okay. Oh, ray direction. I have a function called ray direction. Parameter 1 is not the type. Okay, so float field of view. Okay, people are asking. Thank you for answering in the chat what's going on here. Again, I'm just exploring this briefly to try to understand some aspect of it. So I don't understand what this error is. Let me, an error occurred compiling ray direction, no matching overloaded function found. Oh, do I have to like define these or something? Like, do I have to do something weird? Let's, okay, P5JS shaders. So, this is, I know, do I have to do something to define? Like if I add a function, porting shader toy examples. Let's look at this. U uniform versus I. Okay. Okay. Got it. Yes, GL frag. Okay. Let's look at this. Let me peek at the chat. Yeah, that's exactly why. glfrag. Oh, because it's a vec2. Thank you. Yeah, how come I didn't notice that? Let's see. So I need a float. Yes. A vec2 size. Yes. A vec2 frag coordinate. So this should be .xy. Okay. Yeah, no error now. Thank you. Now I need to make the I. Get the distance, the shortest distance to surface. Okay. If distance is greater than max distance minus epsilon, we didn't hit anything, so the frag color is black. And hit return. There we go. Oh, now we're talking. Oh, I want this to like format itself better, but that's fine. Okay, great. Now, I guess it really wants to be window width and window size. Oh, window height, sorry. Okay, so there's my sphere. This is kind of an awful way to work. I just do not have enough room for the code and what I'm trying to render. That's why I wanted it to be, why can't I just give it like a fixed size? I'm setting the oh, there we go. That's the mistake. Why would I possibly, okay, great. There we go. Okay, I made a sphere using a signed distance function. Okay. Part 1, challenges. What was this from? Oh, this is from Jamie Wong's tutorial. Okay. So I'm going through Jamie Wong's tutorial. Okay. So now we need some surface normals and lighting. How do we find surface normals for a scene defined by a signed distance function? We take the gradient. Gradient of a function at f at point xyz tells you in what direction to move in from xyz to the most rapidly increasing value of f. Okay. Yeah, that makes sense. So instead of taking the real derivative, we'll do an approximation by sampling points around the point on the surface. So in other words, if we think of this sphere, what I'm looking to do is figure out like the sort of perpendicular point, the normal emanating outside the sphere. If I have the formula for the sphere, I could presumably calculate that. I mean, it seems like I should be able to calculate that precisely with the sphere, but maybe it's important to not do that because we might have other kinds of shapes. So this is just look around it and see what the terrain is and then estimate the normal from that. Okay, so let's take this into my shader. I'm going to have to do a lot of, okay, so now I have an estimate normal function. Oh, that's what scene SDF is for. I gotcha. Because in my ray marching, I'm getting the shortest distance to the surface, which should use, it also uses the scene SDF because it's the, why do I have these two functions? They're the same. This receives a point and returns this, which just gives the length -1. I guess this is just to orient where the sphere is. Because like if I change this, whoops. That's making it half the size. Yeah. I need the dot. All right. Just checking out the chat here. Okay. So, all right. So now I have these normals estimated. And, oh, wait, where are we? And then you can calculate the normal at any point on the surface and use that to apply lighting with the Phong reflection model from two lights. Well, all right, let's take a look at this one. Come on, load. It's just being really slow to load. Okay. So lighting. Oh, boy. Oh, boy. So this... Okay. I'm going to have to build up. So clearly I'm not like actually going to do this in the video, but I just want to see like what I can get to work here. So this function should be fine. And then here, where is the lighting applied? Is it in shortest distance to surface? Is it in... Oh, no, I'm in the wrong. That's right, I'm in the wrong one. Okay, let me close this one out. Phong illumination. Boy, there's a lot of extra functions here. I probably could have done something simple. There must be like a simpler way to just add a little bit of lighting and shading. But, oh, and now I have eye time because it's animating. I don't care about that right now. Let's not have it animate. And what else is wrong here? Error, the message failed to execute. Oh, there's more eye time here. I mean, I know that I have a mapping to that with P5. There we go. But I just want to put a light in here. Okay, so let's get rid of that. And then, aha. So now in the main image, we color it according to this illumination function. So if it doesn't hit anything, we still make it black. We get the closest point. So I should be able to, let's bring this in to here. And then I should be able to say, I should be able to add the color, right, just right here. Whoa! And how is this two lights? The closest point on the surface to the eye point along the view ray is the eye plus the distance times the direction. That makes sense. These are like the colors for the lights? Like what are these? Yeah. Why do I need 3 of these? Is it more than one light? Okay. I have to look at Phong illumination. Phong reflection model. Ambient diffuse specular Phong reflection. So I probably could use a simpler light model, but this works well. Ks, specular reflection constant. Kd, diffuse Ka, ambient reflection ratio. Okay. So ambient diffusion and ambient specular. Yeah. The tutorials from the Art of Code YouTuber channel. Yeah, that makes sense. Yeah, I've seen that channel, Art of Code SDF. Yes, this is what I'm trying to do. Thank you very much, Art of Code. I am already subscribed here. Oh boy. Oh yeah, this is gonna be, I'm gonna need to watch this in a lot more detail later. Is there a link to the, yeah. Oh, shader toy. Okay. So in my head, what I was going to do was just very briefly, and let me put this back to, I don't know what. I like having it shiny. I don't know what I'm doing. I don't know what any of these do, and I'm just like messing with the numbers. Oh, it made it. Oh, that's ugly. I kind of prefer something blue. There we go. All right, I'll leave it at that right now. How are there two lights? This is what I don't understand. Oh, because Phong illumination. Oh, I'm actually doing the lights here. So let's get rid of ambient light. Ah, okay. So let's just do one light. Which is simpler. And these would be moving it around. That's probably where I had the like time. That's the light position. Just want to simplify this. Light intensity. That's okay, that's good. So the ambient light, yeah, as soon as I change the size of the, I think I must have like a window resize function in here. Oh, I have window resize, no wonder. That was also messing things up. Okay. So I have a basic, I just want to simplify this. Light pause, light intensity. Okay, I, alpha. What is the alpha? P? No, I. Shininess is the alpha? Ka, Kd, Ks alpha. Aha, yeah, I see. All right. Let me just do something much simpler right now, okay? I want to basically make this as simple as possible. It's also driving me completely insane that this won't like auto format. I wonder if I just paste this into, I should probably do this in Visual Studio Code. I'm not really getting a lot of benefit. Do I need to look at the Discord chat? Hold on, let me just look at my Discord for a second because it's pinging me and I actually, like, I have a meeting scheduled and I want to make sure. Okay, no, I'm good. I'm good. No notification. Let me just quickly check the Coding Train member live chat. Okay, and nobody's in there. Great. Okay, I'm back. I have 4 minutes left on this experiment. Okay, I don't need to fix the. All right, so what I wanted to attempt to do was just change this SDF function to. Thanks, Kfon, for joining. I want to change the SDF function to not be a sphere. So let's go back to Inigo's. Got so many, oh my goodness, so many websites to learn this stuff. Maybe I should stick to my wheelhouse here. I'm going to have to learn this at another time. Maybe I should sign up for a course on shaders. That might be the only way to get me to do it. Where's, yes, okay. So what happens now if I just try to, for example, try to do a box instead? I really don't feel like, I feel like in my mantra of making things really, really simple, I like, whoops, I kind of like the way that this, close this now. I like the way that this is written with float s. Is it going to explain what the s is? It's just subtracting, it's just its position, right? So what if I just simplify no, that's not sample point. Let's keep that. Float s minus s, get rid of this. And I must have done it somewhere else. Oh, I forgot about the normal. Why did I try to rename stuff just now? Oh, because I'm not sending in the arguments. Okay, hold on. Fine. Okay, so if I were to attempt to do this, oh, but I need a vec3 for the box because it's the dimensions. All right, I can figure this out. So if I'm doing a box, I probably should explain what an SDF is, a signed distance function, but today is sort of, right now I'm just doing my own experiment here. I only have 1 minute, 38 seconds. I was gonna try to try to really quickly see if I can get an SDF function for the Mandelbulb right in there. That's probably a harder problem than I'm imagining. So if we do this, and so there is my, and what if I were to say this? There we go. Look, you can't tell, but there's my box. I need to rotate it somehow, which I don't know how to do. I'm going to move the camera. Like if I change the camera, the eye, like why don't I move the eye? Where do I set the eye? Like what if I put the eye off to the side? Ooh, yeah, look at that. Well, that's down. Like, let's just put the eye a little bit to the right. And like, go closer. Oh boy. Okay. But anyway, that works. I was just changing it to a square. All right, so I kind of, do something crazy for a second. No. I want to make this sphere bumpy. So, oh, I could convert it to, anyway, okay. I ran out of time. And I only have a half an hour here. And I got to record a new, all right. So this is something that I'm thinking about. Back to the Mandelbulb. Which is here. So what is there's a version of this, which is me just computing the distance to any given sphere based on spherical coordinates. That's ultimately what this SDF is doing. Here's what I found. Oh, the scene SDF, this is what Same Place is writing. The scene SDF is a function to group all SDF you would have in a scene. Multiple spheres, different objects. Okay. Yeah, this is helpful. 3:30 p.m. is really my like nap time. I'm not getting very far here, but all right, I'm going to be back tomorrow morning, just so you all know. Let me do something here. Where? Remember the wheel that I had? Oh, no, yeah, was it not HTTP server that I ran? Like, this is it, right? How come it's not remembering? Oh, there we go. Oh, thank you. It's not on here. I had an idea for the next coding challenge, Pi Day, which will have to just pick something. Like Mandelbulb is what I did. It's not even on here. That's weird. Remember when I made that whiteboard list of all the things? One of the things was let's see what I'm going to get here. I was thinking, what if I did a coding challenge for Pi Day where I actually learned ray marching more properly? This is not what I was looking to do. Whoa. Yeah, this is what I was kind of thinking of, 2D. Like I've done this before. There's a name for it. What are these like polar graphs? No, but there's a name for what I'm looking for. Yeah, there's sort of a list of GitHubs on topic on a list of topics on GitHub. It's funny. I should just write the code for them. This is a processing example I made 100 years ago. It's probably actually in the examples under math. I'm trying to like think of the name for a thing that I made like 20 years ago. Topics. There used to be a math topic. Textures. No. Simulate. Shaders. No. Did it go away? Is it under basics? Math? Graphing 2D equation. This is what I'm looking for. Look at this. This is what I was thinking about doing. Yeah. So these are fun to play with. There's a name for this. And I thought I put it on the coding challenge list. And it's really just playing around with polar to Cartesian coordinates and then creating a value based on that. And I was thinking, what if I tried to do this in a shader? Graphing. But what's the term for this? The twisty thingies. Radial. Yeah, there's a term for this. All right. Graphing 2D equations. Let's just see. That's very funny to me. That this, of course, is what comes up. Ooh, that's fast. Some like magic port to like JavaScript. I can't believe that this runs. Is this like a shader secretly behind the scenes? Hold on a sec. All right, I got to record a new ending to this video. I can't. P5 canvas. No, it's just a P5 example. Is it just the raw P5 example and it just runs that fast? I find that hard to believe. Like 2D. Yes. Oh, no, I already looked at that. Yeah, this is what I'm looking for. But this is in shaders. I was thinking I could start my journey into SDFs by doing a 2D version of it. Here we go. Yes. Inigo, you are my savior. There we go. Here we go. But these are shader toys, but that's fine. I can do this. This is what I was thinking. What if I, as my coding challenge, tried to do a sort of basic ray marching or kind of like 2D SDF kind of coding challenge example. And I don't even think that I need ray marching because I can literally just color these according to the distance, right? From any given point. And then I could move to doing this into shaders and 3D and eventually get my Mandelbulb. Recursive graphic 2D equation. Parametric equations. Thank you, Simon. Yes. Parametric equations graph. Yeah. So I feel like it's kind of I mean, I've done so many variations of this kind of stuff, but these are really, wouldn't you, ooh, oh, these are crazy. I think a pixel by pixel version of these using the same concepts, but in processing and using a lot of trigonometry functions. These could be an interesting topic. I'm going to have to think about this more. Right now, I just have to record a new ending to the Mandelbulb video. Right, given these shapes, I don't think you can color them by distance unless it's a circle. The whole point of a signed distance function, though, is that I can know for any given point in space what the estimated distance is to the sort of nearest object in the scene. And so in 2D, so for example, if I had two spheres, if I go back to that shader of mine, I should be able to get, whoa, oh my goodness. Wow. There's too much for me to learn in this world. This is not stuff that I ever really did. But I would love to. This is kind of amazing. Okay. This has been one of the more useless streams that I've ever done. So thank you to all who are watching and supporting. A recursive graphic 2D equations kaleidoscope. Do a series on OpenGL with C. I would like to do that. It's funny, I thought I had a different name for it that I put in here. I'm just not remembering anything. Maybe this isn't exactly what I was thinking. All right, hold on. Has anybody done this in processing? What am I about to find? Oh, interesting. Oh, yeah. Whoa. What is this? This is more interesting. I'm going down a lot of rabbit holes here. I should put my timer back on. This is an interesting talk that I should look through. Yeah, see? All right, I'm going to explore this a little bit more later, but this is what I was thinking of, trying to create things that look like this and messing with trigonometry functions. This is a very interesting talk that I should read through later. Not right now. But that was a lovely thing to find. Let's just poke around here, because this is like just a treasure trove of amazing stuff. Yeah. This is everything I love. Avoiding trigonometry. What is this about? Okay. Voxels. Can I do more with voxels? Because I already have the voxels. Oh, so much. Oh, what if I thought of it as like rendering the voxels? Path tracing in 1 hour. Okay, I have to look at this stuff not while I'm live streaming, because this is really what I want to get to for rendering the Mandelbulb. But whoa, okay. I'm going to look at this stuff later. I got to go in 20 minutes, and I need to record the end of the Mandelbulb video. So let me just refresh my brain. I can't believe I'm recording all of this to disk. Just looking at the chat. Thank you, Magic Works. In Blender, add mesh extra objects. It is called a Z math surface. All right, these are all. So this is what I was thinking of doing for Pi Day, like fun things like this. Like I just want to, like if I could just play around with these numbers, we get all sorts of crazy, interesting patterns, and I'm sure I could explore this further with color, etc. But this is something different. Okay. Let me do a stop and a start here, because none of that needs to be uploaded or downloaded, re-downloaded. Okay. All right. Oh no, let's just leave it. That's what it was. Okay, everybody. This was not the most productive session. I apologize for not having anything prepared and kind of attempting to like do something that I didn't get very far with. But I do have a slightly better understanding now of how an SDF works in a shader and what I might want to manipulate in order to render something beyond just a sphere. So, but I might just need to come back and do this tomorrow. But what I think that I want to do is describe I wonder how much more detail could I squeeze out of this. I want to try, like the other thing I wanted to do is I wanted to try rendering this a little bit differently. Like what if I use a billboarding technique of putting image textures facing me, put some colored lights on it. I could also basically color the points according to the sort of number of iterations. But I'm off track, too off track. I'm too off track. I'm just checking the chat to see if anybody was saying anything. All right, I'm just going to have to wrap this up here. Okay. All right, give me a second. Hold on. I'm just going to pull up something briefly. I need to log in here. You're going to get a little behind the scenes in a second. Okay. Hold on. I'm going to show you something in a second. Let me just see where was it? It is at 25:48. 25:48. Okay. So here I'm back, and I'm going to go to
Hello, everyone.
25. So this is the current edit of this video. Here in this post, that these are the shapes that I would get from the power of 2, power of 3, power of 16. Whoa, let's look at that. N is 16 here. Yeah, take a look at that crazy fractal Death Star. So the thing that I'm really, really missing here, and that... All right, so this is where I'm going to cut in. I've seen other demonstrations on shader. This is where I'm going to cut in. Okay, I don't know. I just wanted to watch that to give myself a sense. Okay. Okay. All right. So thank you, everyone, for being here. I'm going to take the next 10 minutes to record a few takes of an explanation to round out this video. The video will be released on YouTube, and it is me walking through how to code this Mandelbulb fractal as a point cloud. And what I want to do at the end of the video is wrap up by referencing. And I'm going to get a piece of, where's my notebook? Use this silly piece of cardboard here. I want to reference, okay, so this is the point cloud, which I could start to sort of like color and light, and maybe, or export to Blender, etc. Okay, so that's the point cloud. I could attempt to make a mesh out of this with toxic libs or Hemesh or even like Mesh Lab. And I'm going to show some results of me attempting to do that. But the sort of class, but the way that I would like to pursue, and I'll have to do this in a future video, is to look at ray marching and signed distance functions. I think I can reference, let me get the name correct here, of Inigo Quiles. Is anybody a Spanish speaker who could help me with that pronunciation? Inigo Quiles has an amazing site, so I'll reference that. And then, also, let's just see, yeah. Wow, look at that. Ah, no! All right, and shader toy. Okay, so this is what I'm going to do to wrap up the video. That's my little script there. And let me just open this and here. And so what you're going to see now is me talking through a bunch of ideas. And then in the sort of post-production of the video, I'm going to try to make maybe like a colored point cloud version. I already did like an attempt with Toxic Libs and with Mesh Lab, so I can show those. And then I can reference and pull up some of these other references for the Ray Marching SDF. Does this actually, I mean, I might not even say Ray Marching because, but anyway. Okay, so that's what, okay, most likely is Inigo. Right. Thanks, Zessel. This is fun to read, Zessel, your comments there. And thanks everybody for being here. So I'm going to attempt to do this new ending to the video now whilst very tired, kind of hungry, and feeling a little dejected, if I'm being perfectly honest, because I don't know what I expected to accomplish today, but I'm realizing this topic is quite difficult and will require a deep investment, not just something that I can just kind of like, I know how distance functions work and a little bit of some math stuff, vectors. All right. Inigo Quiles. Inigo Quiles. Yeah, the YouTube chat was hostile last time. I know, it's very rare. It doesn't really happen. But it was a little, hostile maybe taking it a little bit too far. But, let me just make sure I don't have it. Just checking. Okay. Okay, I'm just looking at this. Okay, I shouldn't be looking at my phone while I'm live streaming. It's the worst. All right, here we go. Let me just, can I please have a just reminder again? Let me just watch the last. Yeah, that's a point cloud Mandelbulb. Look at that. That's a point cloud Mandelbulb. We did it. I mean, it looks nothing like the beauty of the like fully ray traced, rendered, colored, lit Mandelbulbs, but by golly, my brain somehow made it from the start of whatever I started today to this, and I'm very, very happy. The other thing I can play with is what value of n am I using? And we can see here in this post that these are the shapes that I would get from the power of 2, power of 3, power of 16. Whoa, let's look at that. N is 16 here. Yeah, take a look at that crazy fractal Death Star. So the thing that okay. So this is my new ending. Here we go. All right, everybody. I think I should probably acknowledge that I'm doing this after the fact. All right, how am I going to do this? Well, I hope you enjoyed that coding challenge. I am recording a new ending from the future to talk to you about what could possibly happen next. Okay. All right. I only have 5 minutes. I might have to just do this tomorrow. Hi, bonsoir, la France. All right, I'm gonna just give myself like 5 minutes to try to do this, and then I might come back in like a half an hour and record it again, or just tomorrow. I gotta stream, I gotta do something for Pi Day, and like tomorrow or Friday are really my last days to do it, because I'm actually gonna be off for 2 weeks. I'm gonna be, more to come about that, but I'm taking a break. I'm gonna be, my kids have a big spring break from school, so I'm gonna be doing stuff with them, and I'm gonna do like some soundproofing and renovation stuff in this room now that I have the solar power, fixing the heater, so I won't be able to use this room for like 2 weeks. So anyway, all right, let me just give this a whirl. Well, I hope you enjoyed watching that coding challenge. I don't really know how to feel about it, to be perfectly honest, but there's just so much more to do. I hope you enjoyed that coding challenge, and maybe your brain is just bubbling up with all sorts of ideas of what you might try to do next. And probably what you are thinking about, it's what I'm thinking about, is color and lighting and animation. So I've really just scratched the surface by exploring the math. I've really just scratched the surface by exploring the math of the Mandelbulb and putting it into a point cloud. Hold on. Let me just ask for my meeting to start a little bit later. So let me see if I can. Whoops. Okay. Just sending a message to see if I could have 10 more minutes before this thing starts at 4. Okay, we're good. I've got a little extra time. All right, we're going to make this happen. We're going to do the ending of this video. I got to make this coding challenge. I'm going to publish it. I'm not going to worry so much about it. It's going to be fine. People will watch it or they won't watch it. It doesn't matter. I mean, it matters or it doesn't. It's okay. All right. Yeah, someone needs that nap. I know. All right. Hold on. This is also bugging me how the browser is here. All right. Well, I hope you enjoyed that coding. Whatever I did before was better. Can we keep that? We'll try it again. All right. Sorry, I have to cough. Mute my mic. I can't do this. Why can't I do this? I have a whole script here. I wrote out my notes of what I want to talk about. Hi, I'm going to interrupt because I kept going and I went down a bunch of rabbit holes to figure out different ways to render the Mandelbulb, and it's a big Pandora's box of 3D fractals out there, let me tell you. I'm going to interrupt from the future and just kind of wrap this video up. I hope you enjoyed what you got to watch so far. You can check the live stream to see where I wandered off to, but I'll get something eventually that I'm happy with. Knock, knock. Hi, it's Dan from the future. I'm going to wrap up the video because the other Dan from the past, he just went off and tried a whole bunch of things that didn't work. What are you thinking about right now? That was the Mandelbulb, a point cloud version. And you're probably thinking, what, could I add color? Could I add some lights? Could I turn that into some kind of 3D object? Could I animate it? There are so many possibilities, and it's a bit too much for me to bite off here. I don't want to bite anything, frankly. Just write the whole thing in the paper. Okay. Is that Britney Spears? I don't understand. Chat pause due to scroll. I don't want to. No, I want to see the new message. Okay. Hi, sorry, I've got to interrupt. Hi, sorry, I've got to just jump in here. I'm a week later in the future. The past Dan went off down a lot of rabbit holes and trying to do some more stuff with the Mandelbulb. But this, I think, is a point to wrap up the video. There's more. I mean, your mind is probably doing what my mind is doing, which is, could I add color? Could I add animation? How could I make this more into like a 3D model or some kind of form? It's just a point cloud. Yeah, me too. Okay. I'm so close. I'm so close to getting it. Stop right there. Hi, Dan from the future here. Let's wrap up this video. I hope you enjoyed this coding challenge so far, the point cloud Mandelbulb. But your mind is probably doing what my mind tried to do there in the past. It's all very confusing, which is, could I make this into like a mesh or an object or render it or light it and add color and animation? And there are lots of things you could try to do, and I hope to revisit those things. The woman laughing. It's a celebrity from Argentina that is kind of a meme here. Okay, got it. All right. Hi, Dan from the future here. Let's wrap this video up. Dan from the past kept going down a road. There was no train there, or it was off the tracks, and didn't really get anywhere. But I want to talk about what it is that you could think about doing next, what it is that I'm hoping to do next, because I think I've just opened up a lot of possibilities that I need to pursue further in future videos. What I have created, what I have explored here is the math behind the Mandelbulb and rendering it as a point cloud. So there's probably some things that you could try to do even with this. Like, is there some logic by which you could choose different colors for different points of the point cloud? Could you render each point of the point cloud as not just a point, but with a texture or some other kind of shape? Could you save all the points from processing and import them into something like another 3D environment like Blender? There's a wonderful YouTube video. There's a wonderful video about creating the Mandelbulb There's a wonderful video about creating the Mandelbulb in Blender that I would highly suggest you check out. What's that one called? Mandelbulb Blender. Jonas Dichel. Okay. There's a wonderful video from Jonas Dichel about creating the Mandelbulb as a point cloud in Blender. You might also think about, is there a way to you might also look into, you might also consider, is there a way to triangulate all of the points and make it into a mesh, an object, a volume, a surface? I went down this road using, I tried my hand at this a little bit using MeshLab, and you could see some of those I tried my hand a little bit at this using something called MeshLab, and you can see some of the sort of awkward results I'm showing you here. But the Mandelbulb fractal has so much detail to it. It has this sort of, but the Mandelbulb fractal has so much detail to it. It has an infinite zoom. But the Mandelbulb fractal and 3D fractals in general have so much detail to them, so much fine detail at any level of zoom that turning it into a mesh isn't really a viable solution. But the Mandelbulb and other 3D fractals, to render them as a mesh isn't really such a viable solution because of the level of fine, incredible detail. But the Mandelbulb fractal and fractals in general, but the Mandelbulb fractal and fractals in general have so much detail to them that trying to turn it into a mesh isn't a particular viable solution. The most common technique for rendering the most common technique that I found for rendering the Mandelbulb in its full glory is using something called a signed distance function. Array marching is using something called a signed distance function. Yeah, look at this. Shader toy is like down. So funny. The most common technique for rendering the Mandelbulb in its full spectacular glory is using an algorithm called ray marching in combination with a signed distance function. This is a technique that allows you to render different kinds of shapes in 3D, like a sphere or a cube. But you can also use it to render any kind of shape where you can compute the distance from the camera or where you can compute the distance from, you can compute the distance or you can estimate the distance to that shape from the eye or camera that's looking at that shape. And you'll find countless examples of this on Shader Toy. You'll find countless implementations. You'll find countless examples of signed distance functions, all sorts of shapes and landscapes, You'll find countless examples of signed distance functions rendering shapes and landscapes and fractals on Shader Toy and other graphics, and in other graphics environments. And you'll find countless examples of, what am I saying? I completely forgot. And you'll find countless examples of rendering. And you'll find countless examples of rendering shapes and landscapes and 3D fractals like the Mandelbulb using shaders and Shader Toy. There's so many of them. I couldn't show them to you all right now. But if you want to get started on learning about these algorithms, I would love to suggest, But if you want to get started on learning about these algorithms, take a look at the website and YouTube channel from Inigo Quiles. It is a literal treasure trove of graphics tutorials and knowledge. Wow. So I don't want this to be the end. I think I'm going to have to just completely learn how shaders work now, learn about signed distance functions, and return someday. I don't know, in 10 years when you're still watching this video and I haven't done it yet, please let me know in the comments. I'm going to return someday to revisit different techniques for rendering the Mandelbulb in real time, maybe using shaders, maybe using signed distance functions, maybe just using the point cloud in a different way. I don't know yet. If you discover a way to render the Mandelbulb, if you are able to make your own creative twist off this point cloud Mandelbulb, please let me know. Share it with me in the comments, social media, on the Coding Train website, all of the ways. I love you all. I love you for having made it somehow to the end of this video. I can't believe you did. If you did, and thank you. I'll see you soon in the next coding challenge on the Coding Train. Okay. Yes. All right. Mandel smoothie. All right. So I think I gotta go because I'm like already I pushed the meeting back an hour and then I pushed it back 10 minutes. So I'm gonna go. I might redo this again tomorrow. We'll see how that is. I definitely need to I need to figure out what am I doing for pi day, and if I can just sort of take some trigonometry functions, think about pi, maybe do the basics of a shader. I don't know. I got to think about it. I'm stuck, but I'm gonna return to it later. I'll be back live streaming tomorrow and/or Friday on Twitch to record some more stuff, so that there's content to be made and released on YouTube as the weeks trail on. Thanks for tuning in, and I'm just gonna be turning this off on Games Assets Garden. I appreciate that feedback. What if you do an actual pi? So tweet at me at Schiffman. Or file an issue on GitHub if you have ideas for Pi Day. I've gotten nowhere. This is the repo here. I'm going to just quickly put it into the chat. So you can tweet at me at Schiffman. Thank you. All these people are subscribing with their Prime. It's like amazing. You have no idea how much that means to me, because there's a lot of stuff that I want to do with the coding train, and I'm kind of growing and expanding it, but I'm also like, my eyes are too big for my stomach kind of thing, and all this support really is making certain things possible. All right, Game Assets Garden, 1,000 something with a little like spinny, spirally thing. I appreciate you, and I will see you all tomorrow or Friday if you want to come back, or maybe hopefully both, because I just want to get as much stuff done and out of the way before I can. Bits, okay. I'm gonna hit this. I'm gonna put on a little music, which I'm not hearing, but you're hearing. And then I'm gonna switch over, mute my mic and switch over to my Zoom meeting, and see you next time. Oh, that was $10 of bits? Wow, that is very generous of you. I really appreciate it. Mwah. Ring the bell.